I just want to give you guys a little bit of what the book doesn't say about these things. Okay, so here we have page 116, yes, example 4. We are talking about geometry and measurement. Okay, I'll just write geometry. Okay, so we have y equals to x cubed, the regular cubic kind. It's gonna look, I'm just gonna draw it later. Okay, let's say we give a little bit of different flavor into this one here. As we talked about before, whatever number I multiply to the x's, it's gonna make changes horizontally, right? If this number is greater than 1, it's gonna crunch it this way, horizontally. But if this number is less than 0, just like this case, it's gonna stretch it out this way, right? Twice as much. Okay, so it's gonna look like this. So we have a regular, I don't know if this is really true, but it looks like this. This is y is equal to x cubed. But if I have the red one, it's going to stretch out twice as much, so it's going to be something wider like this. Does that make sense? Okay, so book doesn't mention this, but I want to mention one more thing. You guys understand that this can be expressed as 1/8 x cubed, right? This is really saying, if I make this, okay, let's label it with red color. If I make this f of x, what I'm doing here is, I could express it two ways. Either this is f with 1/2 x, or, let me just make this equal to each other. This is 1/8 times f of x, right? So we realize that I could just express this as compressing over y, right? So I am compressing it 8 times vertically like this. So think about this. If I have a blue line stretching like this, if I crunch it this way, then it looks like that. Does that make sense? Okay, so we're just going to summarize that right here. So if I have f of x, and I change that by multiplying some number to x, then I am changing horizontally, horizontal, and number 1, stretch when a is less than 0, less than 1. It should be greater than 0. Let me just rewrite that. Stretch if a is less than 0, less than 1. Keep making the mistake. 2, if it's a compress, if a is greater than 1. Right, it gets this way. Okay, another function, h of x, if I give as a times f of x, then it's vertical change. And you guys know what to do. First thing is stretch if a is greater than 1. 2, compress vertically if a is less than 1, greater than 0. Okay, that's all I wanted to say. Now let's talk about example 5. I think that's a good example for us to start talking about reflections and symmetry. So I just erased the title, but it's okay. All right, so we have example 5. I am looking for natural log x. But I am dealing with two other functions. I'm going to make variations of it. G of x is natural log of minus x, and h of x is minus of natural log x. Okay, one thing we remember about natural log x is that I cannot put 0 or negative number. This domain here, domain of f, is x has to be greater than 0. I'm sure it works the same way here, right? This is a natural log. I cannot put minus value or 0 in there, which means domain of g has to be less than 0. Does that make sense? When you plug in less than 0 number, it's going to give you a positive number, so that's good. Over here, I have no problem with domain, right? I plug in same number, but every time I give number, I'm just going to flip it and then make it minus. So let's start with f of x. Okay, so natural log x looks like this.